Care Management System, Diffie Hellman. Assalamu alaikum. I'm Jahid Hassan, and this is my presentation topic. Now, introduction. We can see one photo of Diffie Hellman and Martin Diffie, Whiteford Diffie and Martin Hellman. These two person developed Diffie-Hellman K exchange algorithm in 1976 to overcome the problem of K agreement and exchange. In this algorithm, two parties can agree on a symmetric key using this technique. This can be used for encryption and decryption. This is algorithm can be used only for key agreement but not for decryption or encryption. It based mathematical principles. Now we can know about review of Diffie-Hellman key exchange algorithm. Firstly, I say we have seen different type cipher techniques, also known about symmetric key algorithm and asymmetric key cryptography in our mind that have one query that arises in symmetric key cryptography is how we communicate the key that is known to be the used in encryption and decryption. As we can see here, see in diagram, let's Alice stay in US and Bob stays in Bangladesh. Now they want to perform communicate and they know that the network is not secure. So they want to perform symmetric key cryptography. So they are going to use some DS or AES such cryptography algorithm. In that case, they have this shared private key. Shared private key would be private among Arise and Bob, and there would be no third party knowing the key. What is the way that they communicate with each other to share the private key? They communicate physically? No, it is not solution. So it has to be done on the network, on the internet, at least one time. It is a inherently linked with symmetric key cryptography, and the reason is because is symmetric only one single key is used both for encryption and decryption. If they are going to be shared with a private key, this private key is used for both encryption and decryption, but it has to private and it cannot be sent to any other third person. Let's see in the diagram, if they are sharing the private key on some internet or network, this whose hacker or intruder can basically, such as Tom, can basically read the private key and then can decrypt the messages that are being passed between Alice and Bob. So, so there has to be some mechanism. So this is where the Diffie-Hellman K exchange algorithm work. Now next one is methodology. We can see here an algorithm about Diffie-Hellman K exchange. So first step is global public element. So we know that they have a global element such as global global key, public key. So q is a prime number and a is less than q, and alpha is the primitive root of q, and 2 is the k generation for user a. So select a private key x a where x is less than q, and now calculation private public key for y a equal x a mod q. So same things will happen can in user b, I mean receiver, and now then calculating the secret key by a and calculating the secret key by b. So we describe it in next slide again. So you can see Alice and Bob. Alice is sender and Bob is receiver. Firstly, Alice and Bob agree upon two large prime number Q and A. These two numbers need not to be secret and can be shared publicly. So Q and A can be shared publicly. Alice chose another large number XA equal 3. It is private to his or her, and calculate that ya equal a power xa mod q. So if we calculate this, we get ya equal to, so because 7 power 7 xa power 3 and mod and q power q value is 11, so it is the result is ya equal to. Then I send this to Bob. So Aaron sent y equal to Aaron sent to its Bob. Here we can see we explain this, and now we go to in Bob who is receiver. So he take a number and he take another large number xb equals 6. So yb equal same as a power xb mod q. So put the value, we can find yb equals 4, and also here we can same thing, and we pass the yb equal 4 to sender, I mean Alice. Now computers have secret key k1 as follow. So he find k1, and this is the secret key, and the equation is yb power xa mod q. So we did not find, don't know here yb, and yb next to is yb value sent from Bob, and yb value is 4. So we find k1 4 power 3 mod 11 equal k2, and we go to in Bob who is receiver, and we see here know that we know that y equal to sent by Alice. So ya power xb mod q समान, so k2 equal to power 6 mod 11, so equal to, so we can see that k in this Alice k1 value is 2, and Bob receiver k2 value is 2. So k1 equal to and k2 equal k1, so k exchange complete. So next one we know about advantage and disadvantage. Thus, in advantage, the sender and receiver do not need any prior knowledge of each other. Once the keys are exchanged, the communication of data can be done through a insecure channel. The sharing of the secret key is safe, and disadvantages are the algorithm cannot be used for any asymmetric key exchange. Similarly, it cannot be used for signing digital signature. Since it doesn't authenticate any party in the transmission, the Diffie-Hellman key exchange is susceptible to a man-in-the-middle attack. Now, conclusion. The Diffie-Hellman key exchange has proved to be useful key exchange system due to its advantage. While it is really tough for someone snooping the network to decrypt the data and get the keys, it is still possible if the numbers generated are not entirely random. Also, the key exchange system makes it possible to do a man-in-the-middle attack. To avoid it, both parties should be very careful at the beginning of the exchange. This is my presentation. Thank you.